Hi, this is Algebra 2, Lesson 86. We're going to talk about greater than, trichotomy, and transitive axioms, and irrational roots. And we're starting on page 355. We're going to start with a little bit of math history. Schools didn't begin introducing number lines in elementary school to explain less than and greater than until the 1960s. Before that, they explained negative numbers in more abstract terms. I was born in 1968, so I grew up with a number line just like you. Most of the new math, as it was called, was too complicated for elementary age kids and their teachers, and has been moved back to high school and college level math books where they belong. But the number line stuck with us. So, let's start with a little bit of review. From Algebra 1, we remember that the domain of an equation or a function is a set of acceptable representatives for x. In this case, here's an example. It says graph x is greater than 3, and our domain is positive integers. So, if we graph this on this number line, x is going to be greater than x. It is not x. And the answers are only going to be positive integers, so it's not going to be the numbers between 3 and 4. So it's going to be, it could be 4, or it could be 5, or we can repeat in that pattern. We don't have to put a 0 on on 3, because since this is positive integers, it's not a straight line through. So the positive integers are going to be 4, 5, 6, 7, 8, 9, 10, etc. More than that. Okay, if we graph x is greater than negative 3, and the domain is real numbers, now that the domain is real numbers, we do need to start with a circle on the line to show that negative 3 is not included in this graph. And then we can put a line here indicating that any of these numbers, including the numbers between negative 2 and negative 1, are included, because those are real numbers. Okay, with that review, let's move to a couple of axioms. The trichotomy axiom and the transitive axioms are fancy names for axioms that are so self-evident that we rarely spell them out, but they can be very useful. The trichotomy axiom says that if one person thinks of a number and asks you to guess what it is, your guess is either going to be equal to the number they're thinking of, or it's going to be less than the number they're thinking of, or it's going to be greater than the number they're thinking of. Those are your only three choices. So x is going to be less than b, or a is going to equal b, or a is going to be greater than b. Those are your three choices. Tri means 3. So this is a trichotomy axiom. Pretty easy, okay? The transitive axiom says that if Alan is larger than Bob and Bob is larger than Carlos, then Alan is larger than Carlos. Or if A is less than B and B is less than C, then A is less than C. If A is greater than B and B is greater than C, then A is greater than C. If A equals B and B equals C, then A equals C. Okay, those are both really self-evident, and we know those. We don't think about them very often. But we can use them for many different ways, and this is one of them. So here we have an example. Graph x is not less than or equal to negative 4. And the domain is negative integers. That means integers. So if x is not less than or equal to negative 4, then x must be greater than negative 4. Those are your only choices. If it's not less than and it's not greater than, then it has to be, if it's not less than and if it's not equal to, then it must be greater than. So now we can graph x is greater than negative 4 with a domain of just negative integers. So it's not going to be negative 4, but it could be negative 3, or negative 2, or negative 1. Those are the only choices. Those are the only negative integers that are greater than negative 4. Okay, now we have graph negative x plus 4 is, that's supposed to be greater than, not greater than or equal to, just greater than 2. And the domain is all real numbers. Okay, let's start by solving this for x. So if negative x plus 4 is not greater than 2, if it's not greater than 2, then we know it's either less than or equal to 2, right? So we can rewrite this negative x plus 4 is less than or equal than 2. So if it's not greater than, it has to be less than or equal to. Okay, now let's solve for x. You can subtract 4 from both sides. You're going to get negative x is less than or equal to negative 2. Now we can get rid of this negative by dividing both sides by negative 1. Remember, when we divide by negatives, we flip the inequality around. So this is going to be x is greater than or equal to 2. If negative x is less than or equal to negative 2, then x is greater than or equal to 2. Now we can graph this. The domain is all real numbers. It's greater than or equal to 2, so we put a closed dot at 2, and it's going to go this way. Okay? Here we have another one. Negative x minus 4 is greater than or equal to negative 2, and our domain is in negative integers. So, I'm pretty sure I wrote that wrong. This is supposed to be, it is not. Sorry about that. So negative 4, negative x minus 4 is not greater than or equal to negative 2, and the domain is negative integers. So if negative x minus 4 is not greater than or equal to negative 2, then negative x minus 4 must be smaller than negative 2. That's our only choice left. Now we can solve for x. We can add 4 to both sides. And negative x is smaller than 2. We can get rid of this negative 1. And remember, when we divide by a negative, we're going to flip the sign. So x is greater than negative 2. X is greater than negative 2, and our domain is only the negative integers. The only negative integer that's greater than negative 2 is negative 1. So that's the graph. Okay, now we're going to talk about irrational roots to completely change subjects. On page 357 in your book, move this to the center. So on page 357, we have a graph of a circle being bisected by a line. We actually used the same exact graph in the last lesson. So let me pull out the work that we did there. Okay, here's where we were solving this equation. We had the equation of the line, which is x squared plus y squared equals 9. We had the equation of the line, which is 2x minus y equals 3. And we went through all of these steps to find the places where the line touched the circle. Here we are. We found that the points where the line touched the circle were at 0 and negative 3 and 12 over 5 and 9 over 5. Okay? If we had done all of this and gotten to this point right here, so we solved this equation for y, we squared it, we substituted the square into this equation, we simplified it a little bit and came out with 5x squared minus 12x equals 0. If we had come to this spot right here and this had not been factorable, then we would have had to find the x and the y by using the quadratic equation. Right? And we would have come out with the exact same answer. So, in this chapter, in this lesson, we are going to be solving for problems like this, but we are not going to be able to factor them out, and we are going to have to use the quadratic equation to find the factors, to find the ordered pairs for x and y. So let's start with this one. Here we have x squared plus y squared equals 9. We see that both of these are squared, which means it's either going to be a circle, an ellipse, or a hyperbola. The coefficients are the same, and this is added. So this is a circle. And we have y minus x equals 1. This is first degree polynomial with two variables, so this graph is going to be a line. Okay, so we're going to start by solving the bottom equation for y, which is going to be, we have y minus x equals 1. So we can add x to both sides. And y equals x plus 1. Okay, now we can square both sides of this equation and get a y squared to substitute into here. So y squared is going to equal x plus 1 times x plus 1. And we can use FOIL to say this is going to be x squared plus 2x plus 1. Okay, now we can substitute this into this equation. We have x squared plus y squared equals 9, and we're going to substitute this into this y squared. We have x squared plus 2x plus 1 equals 9. This makes 2x squared plus 2x plus 1 equals 9. If we subtract 9 from both sides, we get 2x squared plus 2x plus, minus 8 equals 0. Okay, we can factor a 2 out of both sides. So if we divide this side by 2 and this side by 2, we end up with x squared plus x minus 4 equals 0. But now we're stuck. There's no way to factor 4, so this is going to come out with a positive 1. So now we're going to have to use the quadratic formula. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so x equals, our b is 1, so this is minus 1, plus or minus, our b is still 1, so this is going to be 1 squared, which is 1, minus 4 times, our coefficient here is 1, and our number here is negative 4. All over 2 times the coefficient here, which is just 1. So that's just going to be over 1. So this mess equals negative 1 plus or minus the square root of 1, and this is 4 times negative 4. That's negative 16. But it's minus negative 16. So this is 1 plus 16. So this is going to be the square root of 17 over 2. You can't take anything out of 17. It's a prime number. So x is going to equal negative 1/2 plus or minus the square root of 17 over 2. Remember that this is the proper form. Okay, so now our x's are x equals negative 1/2 plus the square root of 17 over 2, or x equals negative 1/2 minus the square root of 17 over 2. Okay, we have these two x's, now we can solve for y's. So we're going to solve for y by substituting this back into this formula right here. So we have y equals our x, which is negative 1/2 plus the square root of 17 over 2 plus 1. And this time over here, y is going to be negative 1/2 minus the square root of 17 over 2 plus 1. Okay, over here, y equals, we've got 1 minus 1/2, which is 1/2, plus the square root of 17 over 2. Over here, we have 1 minus 1/2, so that'll be 1/2 minus the square root of 17 over 2. So our two ordered pairs are, the x here is negative 1/2 plus the square root of 17 over 2, and 1/2 plus the square root of 17 over 2. That's the first ordered pair. And the second ordered pair, written slightly smaller, is negative 1/2 minus the square root of 17 over 2, and 1/2 minus the square root of 17 over 2. Okay, so those are the 2 points where this line crosses this circle. Okay, that's it for that lesson. It's messy, but it's a quadratic formula and you can do that. So, try your practice problems, do your homework, and let me know if you have any questions. Thank you.